Hello friends, so in today's question, a dog with a mass capital M has its string attached to one end of the spring which can move without friction along a horizontal overhead fixed rod. The other end of the spring is fixed to the wall. The spring constant is K. The string is massless and inextensible and it maintains a constant angle of theta with the overhead rod even when the dog moves away. There is friction of coefficient mu between the dog and the ground. What is the maximum distance that the dog moving slowly can stretch the spring beyond its natural length? This is a dog and this angle theta. The spring is on a rod which is fixed at the wall and the string is making the angle of theta with this rod. Okay, so we can divide all the forces into various components. Okay, so this is a spring and we have a string which is making an angle of theta with the horizontal. This angle is theta. Okay, so and we have a tension T, and this tension T can be divided into two components. This component will be coming as T cos of theta, and we are going to have a component T sine of theta, and there will be a force of kx if x is the displacement, and similarly this angle will be also theta, and here also this component can be divided into two. We are going to have T sine of theta and this will be T cos of theta, and there is a friction between the, you can say, dog and the surface. Okay, so that the coefficient of friction is given as F. This will be F, and the weight of the dog is mg, so we are going to have mg in the downward direction, and there will be a normal, let us suppose, that is given as n, which will be equal to mg in the upward direction. So more or less these are the forces which will be acting. Okay, so in this case we are going to find out the maximum distance that the dog moves and stretch the spring beyond this. Okay, now the important thing is that the dog is moving slowly. Okay, so if the dog moves slowly, then all the forces will be, you can say, in the balanced form. Okay, so we can say as the dog moves slowly, it will be always in equilibrium. Okay, it will be always in equilibrium. So you can say for spring, we are going to have T cos of theta minus kx will be equal to 0, and from here we can find out a value of T. So this will be T cos of theta will be equal to kx, and t will be coming as kx divided by cos of theta. Let this be equation number 1. And similarly, we can say for the dog, okay, this is nothing but our dog, let us suppose. Okay. So we can say for dog, we can have f minus t cos of theta is equal to 0, and f will be equal to mu n. We substitute the value, f is equal to mu n, and n is nothing but our mg. So you put f is equal to mu mg in this equation, we get mu mg minus t cos of theta is equal to 0. Okay. So from here we can find out that mu mg is equal to t cos of theta, and t is our kx. Okay, so we have t, so we have mu mg is equal to t cos of theta, and t cos of theta is equal to kx, so this will be equal to kx. Okay, so we can, from here we can say that mu mg is nothing but our n, so mu n will be equal to kx, and n will be equal to kx upon mu. Let this be equation number 2. Okay, and for the in the vertical direction, for dog in vertical direction, we have n plus t sine of theta is equal to mg. Okay. So we are going to use equation 1 and 2, put the value of n as well as t. Let this be equation number 3. Using equation 1 and 2, in equation 3 we get our n is kx upon mu, n is kx upon mu, plus our t is kx upon cos theta multiplied by sine theta is equal to mg. So here we can take kx as common. Okay, so we can say that kx 1 upon mu plus this will be tangent theta and mg, which can be further solved at kx will equal to 1 plus mu tan theta divided by mu is equal to mg, or we can say our kx is equal to mu mg divided by 1 plus mu tangent of theta, or our x is equal to mu mg k1 plus mu tangent of theta. So this is the x is the maximum displacement x is the maximum distance that the man can stretch, that the man moving slowly can stretch the spring beyond its natural length. This question was quite simple. We simply divided the components and used the condition that man is moving slowly, so it means everything will be in equilibrium, and we simply equated the horizontal as well as vertical forces and solved it and found out the value of x, which was coming as mu mg divided by k1 plus mu tangent of theta. Thank you.